Okay, so Olivia and Liam do not like to cook dinner on a Friday night. Liam prefers to order the dinner using a food delivery company, and these companies have an application app through which you can order your food. Okay, so we need to put these solutions somehow down, and we need to get some kind of graph going as well. And we want to try and add as much detail as we can as well in here. So what I'm going to do is the following. Okay, so Olivia and Liam do not like to cook dinner. Friday night, Liam prefers to order dinner. We got our three options. So let's start off by writing down our equations. Okay, so what is the equations for each of the delivery companies, right? So delivery company equations will be given by the following. So option A is given as C equal to 0.4D plus 5, capital C for costs, D for distances. And then we have option B, which is going to be equal to, now we've got a $1 booking fee plus zero point 0.9 per kilometer. So it'll be C equals to zero point 0.9 D plus $1 booking fee. And then we have option C, which is going to be equal to, option C is going to be a flat rate of 15. So C equals to 15. It's going to be my third equation from here. Now we can generate a table of values so that we can plot this onto a graph. All right. If we do, just to show substitution as the distance changes, what will the corresponding C values be? All right. So what we want to do is we want to generate a table of values for this. So we generate in a table of values, we're supplying distances D, and we're substituting the distances in here to get new values. So this is going to be 0.4 times 4 plus 5, which will come to 6.6. $6.60. This is $5. And then this is going to be times 8. We're going to have 6. This is going to be 8. So 8.2. All right. So 8.2 will be the cost for this one, $8.20. And this one here, we got 12, which is going to be $9.80. And 16, which will be, if we substitute 16 here and we add 5, we're going to end up with 11.4. All right. We do the same thing, exactly the same thing for option B. And we create the same kind of table, but we just change up the equation for this. Okay, so if I do have to copy this here, and then just change the equation into C equals to 0.9 plus 1 over here. We're then going to generate values for this one again. Okay, so changing these values means that we are going to have a different line. We're dealing with a completely different line here. It's going to have a different y-intercept, etc. Now you can plot this generally without drawing the table, but we're showing the table so we can prove that we understand substitution. So this is 0.9D plus 1. Okay. All right. So this is going to be, the first one is going to be $1. Okay, at 0. And then we repeat the same process here for each of these, changing that into 4. That'll come to 4.6. Changing this into 8, which is going to be 8.2. So it's going to be 8, which will come to $8.20. What about tedious process? But part of your internal is what you would do if you do this as well. So this is going to be 12. And if you're using a device, this is what it would look like. If not, maybe on the lines of probably. And then 16. Lastly, 15.4. Now the last one is going to be not so bad. All right. The last one is going to be C equals 15 all the way through. So for the last one, option C, where we can actually rewrite each of these equations in actually. C. Adding this in here, we got the cost for each of these is going to be 15. Right, so the cost for each of these will be 15 no matter what. This is unchanging values for the distances. It'll just stay at $15 actually. Don't forget the dollars, and also don't forget you're working two decimal places if you're dealing with money. As often as possible if you're dealing with currency, that's what you would do. Okay, so option C over there. So solution, delivery companies, we've got our table of values. Now we need to put this into our graph. So I'm going to put this into our graph. And so here's Desmos over here. I'm going to put each of these equations. So C equals 0.4D plus 5. That's going to go in there. And I'm going to go C equals 0.9D like that. And then we got the last one, C equals 12, but it doesn't come up and I put C equals 12. So I'm going to put Y equals 12. And that's going to give me this graph over here. Okay. I need to indicate the intersection points. So I'm going to click intersection points like that. And also y-intercepts over here is pretty important as well because it's one starting from 0, 1. We can also see that if we have these intercepts, it can give us an indication of how we should look at in terms of the graph. So let's see if I have to share this graph over here. I could easily do that, right? All right, so I'm going to export image over here, just like that. Download image from here. And we're now going to try to put this image into. Okay, so now inserted the graph. There's our graphs. We have our graphs in there now, which is coming straight from Desmos. That's our question. We've now generated our graphs from here. What we want to do is indicate as well that we have these different points of intersection. The point of intersection at 8 over here. So I need to also remember that this is where these values maybe have to be written in or typed in. But anyway, we could state the intersection points from it. Going back to the question, task A, give the range of values for which the delivery company is the cheapest option. All right, so let's start with that over there. So the range of values for which the delivery company is the cheapest option. We can see at the moment that from this, so from the graph, we can see, let's generate a table. We could develop a table of values, and the table of values will have from 0 up till that intersection point, which is at the moment at 6, 7, 8. The blue line is going to be the, and we have to label each of these lines as well. So each of these lines have to be labeled as well. Okay, putting them all into this here is probably not going to be completely practical right now. But if I have to label this, we did put the first line in here. So this is going to be A, company A. This is company B, option A. Option B is this one, and option C was the green one. And from there, if we go downwards, this is going to go up till 7. This is going to go down all the way down there until I think it's 17.5. And so the table of values will say the range of values, if you're going from 0 to 7, option B would be the lowest cost. If you're going from 7 to 17.5, option A would be the lowest cost, and anything more than 17.5 would produce the other way. And so now we're creating a table of values where we have these options available. Okay. All right, so here we go. So we're going to insert here, insert a table of values where we're going to have those options available. Cheapest option and for each one. Okay, so if we're going to go for range, so from 0 to, which was at the moment, I can actually just keep it on this side open. So we've got from 0 until 8 kilometers. Cheapest option is going to be option, the blue line, which is option B. And if I'm going from 8 until 17.5, So 8 kilometers to 17.5. And if it's on 8 or on 17, then you can choose either one, right? So 8 kilometers to 17.5 kilometers is going to be option number red. And the red option is option A. Option A. And then lastly, above 17.5. You can see now this internal is starting to take shape because there's so much in it that you have to put down when I'm going through it without actually putting it into perspective. You won't actually see how much of detail there is in here, but you can see right now that there is quite a bit of detail in this internal. Correct. We have that as our table of values, and now we can conclude from the question, because we're given lounge suite dining, we could actually suggest now using this table, right? So using the table above, and the distance traveled below, which option will be the best, having the lowest cost. All right, something on this line so you can add much more detail. I'm just trying to squeeze it all into one lesson, right? So I'm going to insert one column to the right here. So if that's the distance, 5.5 lies in option B as the best option. Okay, and 11 is going to be between those two, so option A. And food extravaganza is going to be option C because it's more than that, and that's where the lowest cost would be found. Option C. And remember, these numbers are coming directly from here. So if we're going to go for 5.5, 5.5, we can see is going to be the blue line. And that's lounge suite dining over there. And then you got 11 kilometers, which will get you to the red line, which is option A. All right. And then you got 20 kilometers, which is going to get you to the green line, which is option C. And that's why we have option B, A, and C in that order over there. And this is recommendation where you should travel to based on the lowest cost and the distance that you prefer to travel to or with. So recommend which option. Give the range of values. We've done that, and the delivery company's cheapest option. Recommend which option would be the most affordable for each restaurant. So table above, so we can say most affordable option can be in this column, right? That's what it is. Most affordable options available for this. Okay. All right. So lounge suite dining would go definitely option B as a delivery company. Palace Eats, that, etc. Table above and distance travel below. Which option will be the best, having the lowest cost? Can be shown in column 3. All right. Justify your suggestions using graphs and equations. That would be this graph over here. We would have that. We have it over here as well, and we can see that we can start pointing out stuff on the graph, like inserting arrows, etc., or maybe writing on this thing and actually putting some values in there for task A to justify this a little bit more than that. Okay. All right. So for task B now, we're going to create that equation. And how do you create that equation? You need to first find the gradient for this line. Now we can see that we have a rise of a run. The rise of a run is going to be running across here. That's going to be my rise, and this is going to be run, and this is going to be my rise. So we know this is 17.5. And my run is going to be going from 1 up till 12, so that's going to be 11. So it's going to be C equals to 11 over 17.5, D plus 1, and that's going to be the line that we want to work with. All right, this will come to C equals to 11 over 17.5, which is the same as 22 over 17.5 times 2 is 35, right? 35d, right, as in a bracket, d plus 1 would be the best way to cover all the different costs that we have available there. Okay. And then we have to justify this by stating maybe a table of values and maybe putting it in the graph as well, drawing it in there. Okay. And stating why this option will be the best, will be the best strategy for now than the others. Okay. So to influence the best rights, we can basically look at the gradient and the y-intercept and mention a bit of that. So we can add more detail in there, but we'll stop there for now. And just to give you a good idea of how to get through task A, I guess task B we don't have enough time, but we will. All right, if need be.